Convert 4 pi over 3 radians to degree measure. So to do that, what I'm going to do to start off with is I'm going to write 4 pi divided by 3. And what I'm going to do is I'm going to multiply that by a fraction of 1. Now, in order to convert a radian to a degree, don't you want a pi on the bottom so the pi's disappear? And what equals pi in terms of degrees? Isn't that 180? So again, isn't pi and 180 equal, just in different units? So if I put the pi down here, won't these disappear, leaving me a degree number? That's kind of cool. So real quick, could I cross those out to start with? All right. Next, don't you have 4 times 180 over 3? Now you might be, okay, don't multiply 4 times 180. Can you reduce something that goes into both of these? And hopefully you can see this. Watch this. Could you hopefully see that isn't 180 equal to 3 times 60? Are you okay with that? So could I rewrite this as 4 times 3 times 60 over 3? And then, could I cross out the 3's? I wrote 180 as 3 times 60, cross out the 3's, so don't I now have 4 times 60? And what is 4 times 60? That is 240 degrees. And if you looked at a unit circle, you would notice that 240 degrees is the same as 4 pi over 3. So we're going to convert 225 degrees to radian measures in terms of pi. So in order to do that, we're going to start with 225 degrees. We're going to multiply that by a fraction. Now, if I want to turn it to a radian, don't I want pi on top? Because all radians have a pi on top. Okay. And what degree matches 180? Sorry, what degree matches pi? 180. Now, for some of you, could it help to put a 1 underneath if you want to? Could that make it easier for some of you to put a 1 down there? It's your call. All right. So next, what I want to do is, okay, I multiply across. I have 225 pi over 180. Now, those numbers are way too big. So we have to figure out how to reduce this. First thing I'm going to do is, well, okay, what number goes into both? Well, at first observation, I see that 5 goes into both. But if you look deeper, well, doesn't the unit circle have 45s, 60s, 30s, and 90s? If you're wise, you will understand 45 goes into both. That's a little harder to see, but hopefully you can see over time. And what you'll notice here is the bottom is 4 times 45. The top is 5 times 45. And you have the pi still. Now, again, you might not see that. So if you can't see 45 goes into, could you have done 5? And then find another one and keep reducing slowly? I just noticed 45 is a common one, especially with unit circles. You have 45s, 30s, and 60s tend to be common. You will learn over time to choose wisely and find numbers that go into them. That disappears. Okay, once I cross that out, I am left with 5 pi over 4. And if you look at your unit circle, 5 pi over 4 and 225 degrees should match. Convert negative 7 pi over 6 radians to degree measure. So let's start by writing down negative 7 pi over 6. And to convert it, I'm going to multiply by a fraction. And if I'm trying to get a degree, I want to get rid of pi, so I'm going to put pi in the denominator. Then I got to choose its equal value as a degree, which would be 180. That allows me to cross out my pi's, and now I have a degree, which I have to reduce. So I now have negative 7 times 180 over 6. Now, if you think about this, okay, does 6 go into 180? And yes, it does. So what you hopefully notice is this is 7 times something over 6. And what can I replace 180 by? 6 times 30. So can't you take 180 as 6 times 30? Now the sixes now disappear, don't they? And 7 times 30 is 210. Don't lose the negative. So 210 degrees negative is equivalent to negative 7 pi over 6. Okay, convert negative 450 degrees to radian measure in terms of pi. So this one you can't use your unit circle because it's beyond our unit circle. All right, so negative 450 degrees. I want to multiply that by a fraction. I want to make it a radian, so I'm going to put a pi on top, which its equivalent to pi is 180, so I put 180 on the bottom. It could help to put a 1 underneath. It's your call. Now, before I simplify this, do you guys understand I could cross out the zeros because it's like pulling out a 10. If I pull that 10 out, a GCF of 10 out, that leaves me negative 45 pi over 18. So I could get rid of those zeros. Now, that's still not simplified enough. What I hope you see here isn't, what goes into 45 and 18, hopefully you see as a 9. Can you see the top is 9 times 5, and the bottom is 9 times 2. So that would leave us negative 9 times 2 pi and 9 times, sorry, oops, I take that back. That would leave us right here, that's not a 2. That would leave us a 5 there and a 9 times 2 on the bottom. All right, so that's a 5 right there and a 2 on the bottom. 5 and a 2. And what you would see here is that the 9s disappear, leaving you the negative, don't lose the negative, 5 pi left over on top and a 2 on the bottom, and that would be equivalent to negative 450 degrees.